Hello everyone, welcome back again with the new video. So most of the people have completed almost 1 year for their Hyperledger Fabric production network, and default certificate expiration for the Hyperledger Fabric is 1 year for TLS and enrollment certificate. So that configuration is defined in the configuration file of the certificate authority. To avoid this issue, we have to renew or rotate our certificate on the timely manner. So in case if the certificate get expired, our network won't be running, so we'll get some kind of errors. So that's why this rotation process is one of the most important and critical thing. A lot of people have already faced this production application down issue because their certificates are expired. Because of that, the network were down. So how to overcome this issue? There are multiple approaches. But first of all, so when your network is already down because of the expired certificate, or you can just reproduce the issue to analyze what exactly procedures are there. If you have certificate expired in your network and your network is totally down, to rotate the certificate or renew the certificate, that is one of the complex procedure in the Hyperledger Fabric. So we have to be very careful for each and every operations. Yes, of course, we can recover our network, but we have to follow certain steps. So in this video, we are going to go through all these steps. So let's jump into the VS Code. So on the screen, you can see there are two parts. First one is creating the scenario of expired certificate network. The second scenario is how to renew the certificate of the expired network. So these are the two parts we are going to cover. If you already have your network already down because of the expired certificate, you can start it from directly second part. You don't need to recreate, but just for the demonstration purpose, I'm just recreating that expired certificate network so that we can just replicate exactly all the procedures. First of all, you can see here, to reproduce this issue, we have to set our time back. Right now, you can see current date is 19th of February 2022. Now, what we will do, we'll set our machine's date back to the January month. So you can see here 17th of January. It means in February 19 we will complete one month and 2 days, almost more than 32 days. Okay, and while creating the certificate, we will give an expiration time of 30 days only, so that whenever we switch back to the present date, our network will have expired certificate, and for that we require to renew. So that all the procedures we are going to cover in this video. So first thing is we have to run this command actually, sudo time date ctl set ntp no. Yes, I'm running this command. Don't worry about the network right now. All right. Now we have to run this command. So right now I'm setting the date to 17th of the January in 2022, means 32 days before from the current date. You can see in the calendar now. Yeah, you can see now date is the 17th of the January. Okay, current system date. What we will do in this date, we will create a network and do some kind of transactions. And before doing the transactions, of course, we are going to create the certificate. Everything we are going to do it from the scratch. One more thing, while creating the certificate, I will change the default configuration of the certificate authority to expire the certificate in 30 days. So let's start. If you already followed my previous video series, then you already aware about this Fabric network repo. So it's having each and everything for creating the basic network. You can see this API folder is responsible for creating the API and interact with the network. In the artifacts, we have some script actually, but don't worry about the other things. Like we have to just know about the creating the basic network. And for that, I will go through each and every step. So the first step would be creating the certificate authority for creating the network. So you can see in the artifact folder, we have channel. Inside the channel, there is a create certificate with certificate authority. This is the folder I have to go inside. CD artifact channel create certificate with CA. So I'm currently using Fabric version of 2.2.1. These operations are independent of the Fabric version. Maybe you can try with other version as well, but I tried with 2.2.1. So we are inside the create certificate with CA folder. You can see there is a Docker Compose file, which is responsible for creating all the certificate authority for the organizations. And the topology of our network is we have 3 peer organization and 1 order organization. So it means total 4 organization. So in this Docker Compose file, we have 4 certificate authorities: CA org 1, CA org 2, CA org 3, and finally CA orderer. First step is creating the certificate authority. So here we have 4 certificate authorities, services defined in Docker Compose file inside channel artifacts. Sorry, artifact channel create certificate CA. This is a Docker file. And now I'm just running the Docker file. Docker Compose up in detached mode. So I'm creating the certificate authority. You can see here this Fabric CA folder get created. So inside the Fabric CA folder, we have all the confidential data of the certificate authority for each organization. You can see for order organization, we have certificate authority data for that order organization, and for other peer organization also we have the same thing. There is a configuration file in each certificate authorities organization folder here, Fabric CA config.yaml. So in this section, you can see here at the line number 265 signing, default is the digital signature. That is the enrollment certificate. Generally it get created. This is the certificate authority certificate. Like if some intermediate certificate authority is getting a signed certificate from this certificate authority, then we have the configuration here. Next one is for TLS communication. If we are using the same certificate authority, then that configuration is defined here. And 8760 is the time in hour actually, and it's equivalent to 1 year. So default expiration time of the enrollment certificate, that is 1 year, and default expiration of the TLS certificate is also 1 year. So what we have to do to reproduce our scenario, we can just change this to 1 month. Let me check in the node, in this node.txt. You can see here we are going to change to 720 hours, which is equivalent to 1 month and 30 days. I will show you. Okay, but before changing this configuration, we need to change the permission, because we won't be able to directly change this file. I will show you here. Okay, I'm saving it. We change the permission of this folder. Okay, sudo chmod 777 recursively for this current path. Okay, I'm done. Now I will save it. Yeah, you can see it gets saved. For other organization as well, do the same thing. For order organization, here 720 hours, and here also 720 hours. For order 2, make it 720 hours. For order 3 as well. Sorry, for organization 3. These are the organization for, and these are the order organization. So we have changed this configuration file, Fabric CA server configuration file for all the organization. Now default expiration time is 720 hours, which is equivalent to 30 days. What we can do now, we'll just restart our service. Docker Compose down first. Docker Compose up in detached mode. Now whatever the certificate design, these certificate authorities are going to sign, they will have the enrollment expiry time is 720. Like it means for the enrollment certificate or digital signature, it's 720, and for the TLS certificate, it's having 720. It means 1 month. Now what we have to do, our certificate authority is up and running. Next step is creating the certificate for all the participants in the network. Let me show you here. Just I'm minimizing this. Create certificate with CA. This is the file. Actually, this is a script where we have defined everything. You can just go through from top to bottom and you will get to know. For each organization, we have 1 peer, and in network, we have 3 orderers. So for all the participants, we are just creating the certificates actually, MSP and the Tls certificate. So I'm just running this script now. Create certificate with ashes. You can see the certificates are getting created using the services which we run. You can see here, and crypto config, there would be one folder here, crypto config, and inside this crypto config we have all the certificates for 3 organizations. You can see org1, org2, org3, and inside the organization we have one peer for each organization, and this is the MSP and the TLS folder for this organization one. Respectively, for the other organization also have the kind of same configuration, but they have their different own certificate. For ordering organization, we have different 3 orderers: orderer 1, orderer 2, orderer 3. Next step is creating the channel artifacts. So you can see here, just go back, we have one create artifacts.sh file. I'm just running it, create artifacts. Just let me open as well. So inside the create artifacts, we just creating these profiles actually, Genesis block, channel.transaction file, and anchor pair update transaction files. So using this script, we'll get this file, Genesis block, my channel.transaction, org1, MSP, anchor.transaction. So I'm just deleting this now. It will get auto created. These are the previous networks actually. So I'm just running it, create artifact.sh. You can see here, Genesis block, my channel, org1, 2, 3, anchor pair transactions. Okay, so what is the next step? Next step is running our all these services, peer, orderer, and everything. Again, just go back, and here we have Docker Compose file, which having all the necessary services. Orderer, orderer 2, orderer 3, CouchDB 0, 1, 2, and 3 peers for one peer for each organization actually, total 3 peers, and we have this kind of topology now. So what is the next step? Now we'll run this actually, Docker Compose up in detached mode. All the services are now up and running. For network creation, we require peer, orderer, CouchDB, and certificate authorities are already running. So it means total we have almost these 9 services plus that 4 certificate authority services. And at the runtime, when we deploy the chain code, there would be additional 3 chain code container as well. So here, just go back, and there is a channel creation script, create channel.sh. So this is just the basic things actually. I'm just creating my network so that we can just reproduce the scenario for expired certificate network. Now I'm just running create channel.sh. You can just check the content of this file if you want to get more details on it. Next one is the deploy chain code. Deploy chain code is again one more stick. You can see here, just go through it, you will get to know. We have already gone through in the previous video series. Just I'm deploying the chain code. It requires little time. Once it is deployed, now what we can do from the API side, we'll try to invoke some transactions, and after that we will change our system time to the current date. It means from 17 Jan to 19 Feb, it's almost more than 32 days. So the certificate will get expired. You can see here this chain code deployment is done. Now what we can do, just go to the okay. So currently I'm in API 2.0 folder only. It is available Fabric Network 2.x. So inside this folder, go to the config and create the connection profiles with the new certificate. We already have the new certificate for the peer. Generate ccp.sh is the script which create the connection profile automatically. Just go back and start our server, Node.js app. Now our server is up and running. We can invoke the transaction as well. From the Postman, let me show you here. I'm going to invoke some transaction. Okay, so our server is running, register user. This is the API for registering the user actually. So test1 is the user. I'm sending registration request. We got a token. So this user is already registered and enrolled as well. In the wallet folder, we can see that part. Let me show you here. In the app 2.0, org1 wallet, admin, and test1.id. So this is the test1 user's identity. It's having public key, private key, certificate. So actually public key is available inside the certificate only. So now using this token, I'm going to create a car. So I'm assuming you're already familiar with the smart contract which I already deployed. This is just a fab car actually. You can just go through it. This is the data I'm going to add. Okay, after maybe a couple of seconds, we'll get a response, and this we can just verify it in the cows DB as well. Admin and admin PW is the password, and you can see my channel underscore fab car, and this is the Tesla 200, the car which we have just created before some time. Okay, so now our network is already up and running perfectly. What we can do now, just change the system time to the current one. For that, so as per our notes given here, what we can do, you can just run this command, sudo time date ctl set ntp yes. So I'm currently using Ubuntu version 18.0. Okay, so for this I'm just using this command, sudo time ctl set ntp yes. This will change the date time to the current present time. Okay, so now you can see here in the calendar, the current date is 19. Now we'll check the log as well. Docker ps. We have already services up and running, but just check the log. Docker logs. order.example.com -f follow. You can see here it's showing this certificate of orderer 3 expired less than 86 hours. It means before 86 hours it got expired because it's completed 30 days. And the certificate details as well we can see actually. Let me show that one of the certificate, crypto config orderer MSP. Orderer TLS, and we can just check this certificate actually. Okay, I'm just pasting it. You can see the expiry valid from 16 Jan to 15 Feb. So it means on the 15 February it's got expired. So we cannot use that certificate anymore. That's why we're getting this warning. Now all the components in our network have expired TLS certificate and the enrollment certificate. So what is the next step? Let's go to the VS Code and check the notes. So here the first part we have already completed. So we have set time to the back, created our network from the scratch, set properly enrollment expiration time to 720 hours, which is equivalent to 30 days, created the network participant certificate with certificate authority, created artifacts. Another one thing, we have persisted the data. You can see in the Docker Compose file of all the services, we have data persisted in the volumes. For each peer, we have persisted the data /var pavan /peer 0 or 3, and that volume is mounted to the /var Hyperledger production. For all the other services also, we have done the same thing. So we have make sure you also persist the data. Another one is create channel and deploying. We already done it, and invoke the transaction as well. We have switched our time to the current time as well. Okay, so up to here we are done. If you already have the network which is expired certificate, because of the expired certificate you are not able to do any transaction and all, you can just skip this part actually. Up to here you can just skip it and try it from the second part. So in the second part, what we have to do now, current time is 19 Feb. It means the present time. We have to renew our certificates. So for renewing the certificate, you can see here, renew cert.sh. There is a file. what I'm doing here, just I'm renewing the certificate. Renewing the certificate in the sense I'm just re-enrolling the same components again for certificate. So for all the participant in the network. So for one organization, I will show you here. Again, this is the config.yaml file. So generating the MSP for the peer 0, TLS certificate for the peer 0, for organization 2 also same, 3, and finally order organization. So I'm just going to run this again. CD channel, CD artifact, sorry, channel create certificate CA, and there is a renew cert.sh. I'm going to run this, and this will create again the new certificate in one of the folder. New certificate here we'll create one more folder here, and inside that folder we will have these all the renewed certificate. And make again one more thing I want to explicitly add here. This certificate also have the expiry of 30 days. If you want to change that, make sure to change in the certificate authority configuration file, which we have done before some time. So just for the demonstration purpose, I'm just keeping it for the 1 month again from this date. From 19 Feb to 19 March, it would be having the expiry. So again, we have to do the same thing. So make sure you have a proper expiry for your certificate while renewing it. So I'm just creating the renew cert.sh. It's creating all the certificate you can see here. New certificate, orderer, peer, and inside this we have all the new certificates. So what is the next step now? So next step, once we are done with this step, so in the orderer service, we have some kind of environmental variable we have to add. So at the top, we can see here. Okay, now our certificate got expired before 3 days, almost 3 to 4 days maximum. So for that, so according to it, you have to change this TLS actually time shift parameters. Right now I'm doing 200, which is equivalent to more than 4 days. So I'm just adding it, but as per your requirement, make sure to have this proper time shift parameter. So in my case, it's almost 4 days. It's not more than 4 days. So that's why I have added 200 hours, which is equivalent to more than 4 days. For all the orders also, we have to do the same thing. So for 3 orderers, I'm just now going to run this, restart the orderers. Docker compose up in detach mode. So we have restarted our orderer server with this new three environmental variables actually, which is required. So what is the next step? Next step is the, okay. So in our case, we have enrolled certificate also expired, enrollment certificate. The first thing what we'll do, we'll just replace those newly created MSP for each and every participant. So at the left, you can see here. Crypto config and newly certificate. Okay, first we'll try with for the orderer. This MSP we have to change. I'm just deleting it. And from here, I'm copying it. Orderer, copy. Paste. You can see. Okay, for the orderer 2 as well, do the same thing. For orderer 2, MSP, just copy it. And just delete this. And paste it. For orderer 3 as well, do the same thing. Copy. Just delete this. And paste it. Okay, so we're done with the orderers actually. So next step would be the for peer organization as well. for org1 ps, this MSP got, we have to delete it, and from here just copy and paste it. Because this new certificate have latest certificate which having expiry in the March, means 30 days after today's date. This is for organization 1, for organization 2 also same thing. PS, copy, delete it and paste again. For organization 3 as well, we have to do the same thing. Okay, so we have pasted all the necessary MSP. We can restart our services. Docker compose down. Docker compose up in detached mode. And now we will see the log again. It's getting restarted, but still we have a TLS expired certificate. For TLS expired certificate, we have some procedure. So it's not a straightforward, just like replacing this MSP folder. These are the enrollment certificate we have just done. But for the TLS certificate, the procedure is different. We have to make configuration update. I will show you here. So we have to make the configuration update because orderer TLS certificates are involved in Genesis block. While creating the Genesis block, we have added, let me show you the config.txt.yaml file. Here, this file. At the bottom, you can see here, for the raft consenters, we have added the client TLS certificate. So this certificate we have to update actually for each orderer. And one more twist here, you cannot update all the orderer certificate at the same time. We have to do this configuration update once at a time. So it means we require 3 configuration update transactions for this. Another one twist, if we have multiple channel, of course we have right now application channel and the system channel, one application and one system channel. So for that we require to make these 2 transactions for each. For one channel we have to make this configuration, for another channel as well we have to make the same configuration update. So it means total 3 orders are there and 2 channels are there. Total 3 into 2, 6 configuration update we have to make. So let's start with that procedure now. Now you can see our TLS certificates are not yet renewed. So for that, you so in the create certificate CA, there is a rotate certificate folder there. So inside this rotate certificate, there are a couple of steps I defined. So step 1, step 2. Step 1 for system channel. This step 1 is involved for the system channel and step 2 is involved for the application channel. So first of all, we have to do for the system channel. Let me show you this file. So in this file, what we are doing here, we are using new orderer TLS certificate, which is generated in the new new certificate, and using the MSP configuration path, which we have created newly admin actually, because admins are also get expired. So we have created new admin as well for the orderer. Next step would be the configuration update is the process where we have to face the configuration block, add the update, sign the transaction and send to the orderer. So these are the different steps involved. I will show you here. Just let me comment this part. We'll go through step by step. First is getting the configuration, let us configuration block from the orderer, and make sure we pass this TLS handshake time shift 200, which we have already set in the environmental file. So using this, you will get to know like it will fetch a one configuration block. Let's try to run this. Step 1, orderer. You can see here we have this. Okay, orderer 1 folder is there. So inside the orderer 1, you can see we have one file, and this is the file. I'm just running it now. Add or TLS org1 system channel.sh. First step I'm just running. You can see we got this configuration block. Now what we have to do, this configuration block, we have to decode it in the JSON format. Again, I'm doing it. You can see config.json file got created. Now I'm just copying this and creating one modified configuration block. Modified configuration block. So next step would be we have to encode the certificate into base 64. So this is a TLS certificate which we have created for the new orderer 1. I'm just converting into the base 64. You can see here, this is the certificate. This certificate we have to add in the modified configuration block. Copy modified config block, go to the bottom. You can see here consensus type, and these are the consensus you can see for the orderer. So this part we have to change at the end. Control V. I just copied from it there. You can do it, maybe automate this process actually using JQ. Okay, we have changed this. Now what is the next step? So next step would be, let me execute here. Again, we have to make this update actually. For modified configuration block, you can see we are again encoding it to the protocol format. This original config JSON block and modified JSON block. We are doing the compute update, and finally again decoding it part, adding this wrapper actually, and again encoding, and finally we are sending to the orderer. So these are the different steps involved in the configuration update actually. So I'm just running all these steps again at the same time. Now we should get a successful response from the orderer. Yeah, successfully submitted a channel update. Okay, so we have successfully submitted. Just do the same procedure for application channel as well. In the step 2, go to the step 2. Step 2, orderer 1. Okay. Step 2, orderer 1. Also, we have the same thing. Yeah, I mean, I'm not going to run one by one. You can just go through it. Just confirm it if these are getting successfully executed. So I'm doing the same thing again here. I'm running first 4 because I have to add this TLS file in the modified JSON block. Just copy this part, or maybe you can automate this process. Make sure to add only for the first order of this, for this case. At the end, save it and run remaining part. Successfully submitted a channel update. Okay, so now we have done successfully updation of the TLS certificate. Now what is the next step? Next step is changing the TLS certificate for the orderer. So by default, this Docker Compose file we have is taking all the certificate from the crypto config, this folder. What we have to do in the orderer, here we have already changed the MSP. Now we have to change the TLS certificate. Okay, so for that, for the orderer 1, we have just successfully submitted the updates. Just do for the orderer 1 only. New certificate, orderer 1, copy, paste it. Yeah, we have Tls certificate. Now we have to restart the orderer. Docker restart orderer. Check the log for the orderer. Let's see. Okay, for orderer 2 and orderer 3, still these having expired certificate. But for the orderer 1, we have done successfully update. Same way we have to do it for the orderer 2 and orderer 3 as well. Again, go to the step 1. Step 1, orderer 2. Do the same thing. You can just automate this process using JQ. Just add this whatever the decode, encoded file, this content of the file to the directly in the modified JSON. Go to the particular, in that particular position. Okay, I'm just doing little fast now. Modify. So make sure this time we have to change the second orderer, not the first one. So first one is already having an update latest Tls certificate. So again, I'm doing this configuration update. Yeah, successfully submitted a channel update. Okay, we have done for the order 2 for the system channel. Now it's time to do for the application channel. Again, go to the step 1, orderer 2. Sorry, step 2, orderer 1, orderer 2. I'm running it again. Got certificate here and faced a configuration block as well. Go to the modified JSON. Change for the second position only. Make sure to have second position. Second order actually. So these are the very important steps. We have to very careful, because if we're missing something or single step as well, it can spoil our whole day or maybe whole week sometime. Again, submitting it. Successfully submitted. Now again, we have to move the Tls certificate for the orderer 2 as well. Let me do it right now. Copy. Delete previous one. Paste it. You can make sure to have the backup or somewhere. So I'm restarting the orderer 2 now. Docker restart orderer 2. We can see the log actually here. Orderer 1 log, but we will get that orderer 3 only having expired certificate. Now it will run properly. We have to do for orderer 3 as well the same steps. Go to the step 1. Orderer 3. Step 1, orderer 3 is there. Here. I'm going to run this step now. We got decoded, encoded base 64. Go to the modified config. Now this time we are doing for the orderer 3. So make sure to do it for the orderer 3. This one. I know it's a quite lengthy video, but the steps are very important and we have to be very careful. Okay. I'm running again. Okay, successfully submitted a channel update. Just wait for the application channel because we have done for the system channel here. Step 2, orderer 3. Same thing. We have to do this for the 6 times actually. So you will get used to actually for this. Go to the modified config JSON. For the third orderer, we have to do the update. Okay, so for third orderer as well, we have done the same thing. Now it's time to restart the orderer actually, but we have to change the TLS folder as well for orderer 3. For orderer 3, copy it from newly created. Copy. Delete it, older one. Paste it, new one. And restart the orderer 3. I know it's a complex procedure, but we have to do actually. Without this, we won't be able to do anything. Okay, so now all the orders are updated successfully. What we can do now, just invoke the transactions. But before invoking the transactions, our peer certificate as well got expired, Tls certificate. So those also we have created. We have previously replaced all the MSP that are the enrollment certificate. So for peer as well, we will do the same thing with the TLS certificate. Peers, so in there is a TLS folder, so we'll replace with the newer one. Go to the peer organization with newly created certificate org1 peers. Copy this, delete this, and paste it, new one. We have TLS. Okay, so do it for the organization 2 as well. org2 peers TLS, delete this and paste it. We're done for the organization 2 as well. Next is the organization 3, peers, organization 3, copy, delete this one and paste new one. All right, so we have done all the update which is required. The configuration update is required for a TLS certificate of the orderer only. But for the peer, we can just replace all the folder, newly created certificate folder for the enrollment as well and for the TLS as well. So what is the next step now? Next step, just restart all the services. Go to the artifacts, Docker compose down, Docker compose up in detach mode. All right, so we have latest certificate in our network which we have created before some time. So now we another one thing, we had one previous Tesla 200 car in the network, so we should have that all the data actually. So let's see. Still we have this 200. So what we can do now, we'll just invoke the transactions. But before invoking the transaction from the API, we have to create the connection profile, right? Because we have new certificate now, peer certificate. That is the TLS certificate. And in the connection profile, we have that data only. In the config, I will show you just here, config. Okay, for the connection org1, you can see this TLS certificate we require for that peers. So we have new TLS certificate. Now what we have to do, we have to recreate this connection profile for each organization. generate ccp.ss. It will create all the connection profile for org1, org1, org2, org3. Go back, node1 app.js. Okay, so now we have started our server. Now, next step would be the invoking the transactions. Let me just take a Postman on this screen. All right, what we can do now, just register the user. Okay, we got this. There is another one twist. I just deliberately doing this. Let me explain that part as well. But before we'll try to recreate the scenario. We'll get error here. Okay, no valid response from peer. Just check the response from peer as well here. Identity expired. Okay, we are getting the identity expired because whatever the identity we have created for the user, those are already expired. Because whenever we are creating any enrollment identity, it's having by default 30 days expiry. And in the previous session only, like on 15th of the January, we have created the network, done the transaction as well, and it's already 1 month. So those admin identity and the test one identities are got expired anyway. So just delete this admin identity. We can just re-enroll again actually. Sorry. So now what we can do, register with the new user. Why new user? I will let you know. Okay, test2. The admin identity will get created automatically, and for test2 as well, we will have the new identity which having expiry after 30 days from today's date. Okay, so I'm just creating a car, so having this time Tesla 202, and in the authorizations I'm adding a new token which got created from user2. I'm invoking the transaction now. It should get invoked and our network is properly running. I will show you the data as well. Just go back here and just check Tesla 202. It means we are able to invoke the transactions from the SDK, and our network has already recovered with the new latest certificate having the expiry again next 30 days. But make sure you have a proper expiry. At least by default 1 year is the recommended. After 1 year we have to rotate the certificate before expiration. Let's consider, so right now in our case we have 30 days expiry. It means these will get expired on the 19th of the March, but before that we have to rotate the certificate. For rotation of the certificate we have to use this kind of script, or maybe you can reuse the same script actually for doing the configuration update, and that is very important. So as per the steps mentioned here, we have done all the steps from scratch. In case you have already expired network, so you can just start from the part 2 only. And in case if you guys have any kind of issue, you can just get in touch with me on the Instagram or maybe YouTube chat as well. Another one thing, you can just check the log of the different services. Now you will not get this kind of warning or something errors. So let me show you order log now. You can see here everything is working perfectly as expected. So we have successfully updated the configuration of the application and the channel block especially. So one more thing, in case if you have multiple application channel, then you have to do these steps multiple times, and at the same time you can do it only for the orderer one. So make sure if we have maybe 5 or 7 orderers, you have to do it for the 5 or 7 times, because in our case we have 3 orderers, so I have done three times for each channel. So it means total 2 channels are there. 3 into 2, 6 configuration updates I have done. So in your case, let's consider you have 1 application channel and 1 system channel, but 5 orderers. So you have to do it 5 into 2, 10 times. The configuration update you might have to do for the 10 times, 10 different configuration update. One more thing I want to explicitly add here. So these are the script. You will feel little complex initially, but when you are doing it frequently, it's I mean just like a normal script only. So yeah, configuration update is always kind of little complex, not too much complex, but once you are doing this kind of 6 or 10 configuration update in a 1 or 2 iteration only, you will get to know like this is just a straightforward process. But we have to be very careful while doing each and every steps. Make sure to follow each and every steps. Don't skip anything, otherwise you won't be able to run the network or maybe recover the network if we have expired certificate. For certificate rotations, first part is not required. You can start from the second as well. I mean second only. The second part is responsible for creating or renewing the certificate or rotating the certificate for the orderer and all the participant. So you can have enrollment certificate and the Tls certificate expiry as per your own custom requirement. But yeah, make sure to have it at least for the 1 year. I mean 1 year, and recommended time is 1 year only for the TLS and the enrollment certificate expiration. So one more thing I want to add here. So why we have used the register? Why you have used this test 2 user for the registration? Why we couldn't use test 1 user? So in the API, there is another one twist. In the API, you can see there is a helper method. So inside the helper method, we have this registration process. We are just checking that user is there. And what is the process for registering the user? Admin of the certificate authority first register that user, and after that enroll. So these are the 2 steps involved. So while registering, if we are giving our own password, then we can reuse that password for the re-enrollment. But in case if we are registering without any password, certificate authority will give one secret. You can see here ca.register. In this process, we are not explicitly mentioning any kind of password for this user, for whatever the user we are getting. So that after successful registration, certificate authority returning one secret. Using this secret only we can re-enroll or enroll again. But this secret we are not storing anywhere. We don't have this secret because we are not storing anywhere, and we won't be able to re-enroll as per my understanding. So while registration process, we have to store this secret anywhere so that we can re-enroll the same user and get the new certificate. So make sure to save this secret somewhere, or just pass some kind of password. Just like in the create certificate with CA, there are some script, right? Let me show you for the registration. You can see here for the registration process, I mean for any kind of user, here also we are doing the same kind of registration process, but from the CLI using Fabric CA client. You can see here Fabric CA client register, CA name is this one, ID is the user one, and the secret is user one PW. It means we are explicitly providing this secret. If we are providing this, then we can reuse this same secret for re-enrollment. And for the admin, we are already doing it, because for the admin, secrets are getting used while creating the certificate authority service only. And by default, we are using admin and admin PW. And that's why if we don't have admin identity here, we are just re-enrolling using that admin and admin PW credential. So make sure while in the API, make sure while registering the user, either pass a secret, or whatever the secret we are getting from the certificate authority, you can store it somewhere so that you can get a renew certificate for the same user. That's it for the video. I know it's a lengthy because there are a lot of complex steps involved in it, but make sure to follow each and every step and just try to do this exercise 2 or 3 times. You will feel it's kind of straightforward and easy only, just like a normal other operations in the Hyperledger Fabric. Thank you so much for watching. Stay tuned for the more update.